Hello, I'm Peter Ruggiero from Oregon State University, and I'd like to tell you about a series of collaborative and transdisciplinary projects collectively known as Envisioning Resilient Coastal Futures, exploring alternative scenarios for the U.S. Pacific Northwest coastline. So I think we're all very well aware of the range of climate controls on changing coastal community resilience to flooding and erosion, things like sea level rise informed with regional variability, vertical land motion, and so range from major El Nino events to La Nina conditions, and then obviously trends in variability in storminess patterns and associated nearshore processes. This project also wants to focus on the socioeconomic controls of changing coastal community resilience to these hazards, things like population growth, development patterns, and then the series of adaptation planning exercises that are at coastal communities' disposal, thinking about how to handle hazards into the future. So these efforts are basically taking both a climate and a policy lens, thinking about coastal hazards today, as well as coastal hazards into the future under a range of different scenarios. So again, the effort here is to envision a range of alternative coastal futures, exploring how the complex coupled naturally human systems dynamically respond to a variety of different scenarios. So the projects that I'm talking about have an overarching goal of co-developing, so really using the co-production of knowledge as much as we possibly can. So co-developing the information and tools necessary to envision future scenarios, assess impacts and vulnerability associated with both erosion and flood hazards, and initiate climate resilient adaptation strategies. And so coastal communities are already struggling with issues about hardening shorelines, nourishing shorelines, potentially managed retreat. We performed these studies in both Tillamook County, Oregon several years ago, as well as Grays Harbor County a couple years ago, and now we're actually continuing on looking at the full length of the Oregon coast with a third project. The approach we take is using an agent-based spatially explicit model referred to as Envision, which allows for us to incorporate a whole slew of landscape data into our model. The model Envision allows for basically population growth and development patterns under today's urban growth boundaries or a set of future scenarios that our coastal community stakeholders want to implement on the landscape to actually allocate new infrastructure in a particular coastal community that actually accommodates that population growth. We obviously also plug in a variety of different landscape change models, such as coastal change or total water level type models that are stochastically driven into this agent-based model to actually predict, again, present day and or future coastal hazards. We then developed with our coastal stakeholders a suite of policy scenario narratives and climate impact change scenarios, and then we run the model into the future and then explore a whole wide variety of resilience metrics, things like what's listed on the right-hand side of this definition sketch. So again, I want to stress that this work, both in Grays Harbor County, Washington, Tillamook County, Oregon, was truly an exercise in co-development. We worked hard developing a suite of policy scenarios, which are a collection of individual policies, and then we were able to actually incorporate that into this agent-based model and share results with our stakeholders, iterate on model assumptions and parameters, and develop final products. It's kind of just an overall sketch of how we approach this. We basically derive a suite of individual policy scenarios that basically combine like-minded individual policies that are then coded up into Envision. Things like constructing hard engineering structures, maintaining the beach with nourishment or dune construction, hazard development restrictions, such as setback zones, or removing critical infrastructure from hazard zones, implementing managed retreat. And so we combine the individual policies and scenarios with the climate change scenarios, kind of a range of sea level rise futures from relatively low impact to high impact. And then we let the model run. And so by implementing basically triggers for when these different policy scenarios are going to be implemented on the landscape, and as the coastal hazards increase with these different sea level rise into the future, we can actually determine along the landscape when coasts will actually start implementing some of these adaptation measures, such as armoring. So this is just a simple example of armoring over the Rockaway Beach littoral cell in Tillamook County, Oregon. We can see that by 2040, a good chunk of this stretch of coast is expected to be armored under the status quo scenario, and we can let that play out for the rest of the scenario. Again, we can do this for a whole range of policy scenarios, a range of climate scenarios. Then we could actually look at a suite of policy-driven trade-offs and resilience metrics, such as the trade-off between coastal protection by armoring a stretch of coastline versus coastal recreational services by having a wide beach width out in front. We can actually see, obviously, as in some scenarios where we're actually increasing coastal protection. In the case of high sea level rise scenarios, we also have a situation where we're reducing that coastal recreation service. So we do with a bunch of general conclusions. Basically, these projects in the co-development process allowed us to explore and visualize a wide range of changing climate and management policies on the coast. It's simple, modular, and transferable over a variety of locations and scales. We apply probabilistic methodologies to our hazard modeling to incorporate climate uncertainty. And as I said, we can help decision makers consider trade-offs, cost benefits, pros, cons, etc., and allow for science-based decisions that can hopefully increase adaptive capacity of coastal communities. Thank you very much for your time.